Hello everyone and welcome to my presentation. I'll be presenting a 2008 study titled Neural Substrates of Spontaneous Musical Performance, an fMRI study of jazz improvisation conducted by Charles Limb and Alan Brown. As someone who both sings and plays piano and regularly improvises, I've always been deeply curious about what happens in the brains when we create music on the spot. The study uses fMRI to explore how the brain supports spontaneous musical creativity, and I find it especially fascinating. In this presentation, I'll walk you through the key questions the researchers aimed to answer, the design of their experiment, what they discovered, and why these findings are significant not just for music, but for understanding human creativity as a whole. The issue this study addresses is the neural basis of creativity, and more specifically, how the brain supports spontaneous creative behavior. Human creativity is central to music, art, language, problem solving, but it's incredibly hard to measure or observe scientifically. What's actually happening in the brain during creative moments is a major challenge for neuroscience. While we can study the brain's responses to tasks that are already familiar, things we've practiced and memorized, creativity doesn't follow the same patterns. It emerges in the moment, often seemingly out of nowhere. At its core, creativity in any form involves generating something new, something that hasn't existed before. But what does the brain look like when it's doing this? Which areas of the brain are engaged when we step into the unknown and create something entirely new? And perhaps even more intriguingly, which areas are suppressed during this process? These are some of the questions that neuroscience is working to answer, and the study specifically sets out to address them within the context of music, using jazz improvisation as a model. Now, jazz improvisation presents a unique opportunity because it's a structured yet spontaneous form of creativity. In jazz, musicians improvise, they create new music in real time, but they still do so within an established framework of musical rules. They play off chord progressions, rhythm patterns, and melodic structures, but what they create is unique to the moment. This kind of creativity is not purely random. It's a blend of instinct, intuition, and skill. And it's all within certain boundaries. So it's this balance between structure and freedom that makes improvisation a particularly rich and useful case study for neuroscience. The structure in jazz improvisation offers a framework that allows us to control certain variables, while the spontaneity offers a window into real-time creative thinking. Ultimately, the findings of this study help us understand how the brain supports creativity, a fundamental aspect of what it means to be human. And by looking at how the brain functions during jazz improvisation, we're not just studying music, but we're gaining insights into the nature of creativity itself, and the potential for future research in this area could have profound effects on education, art, psychology, and even therapy. The study poses three central research questions to understand the underlying neural mechanisms of improvisation. The first and most fundamental question was, which regions of the brain are engaged when musicians are actively creating music on the spot? The second question the researchers investigated is how the brain's activity during improvisation compares to when musicians are playing a memorized piece, something they've practiced extensively and can perform without any creative input. The hypothesis here was that improvisation, being spontaneous and unstructured, would activate a different set of brain areas compared to a familiar, rehearsed performance. One key insight from this part of the research is that improvisation, unlike memorized performance, would likely involve areas of the brain responsible for free-flowing expression and possibly emotional engagement. Finally, the researchers wanted to explore how improvisation taps into networks related to language, emotion, and self-expression. We know that these brain systems are deeply intertwined with creativity, so the study hypothesized that improvisation would engage the medial prefrontal cortex, a region linked with self-expression, autobiographical memory, and internally motivated behavior. This area is responsible for reflecting the, quote, sense of self, end quote. And the researchers speculated that deactivating certain prefrontal regions involved in self-monitoring might allow improvisers to let go and create freely without being overly concerned about judgment or self-criticism. What's also fascinating is that improvisation might not just involve motor and auditory processing centers, but may also draw upon language networks. This idea stems from the hypothesis that just like when we speak or tell stories, improvisation could involve parts of the brain responsible for language production. It could also be closely linked to emotional expression, especially since many improvisers are not just creating sounds, but are also expressing deep emotional content in the moment. To address the research questions, the researchers employed functional magnetic resonance imaging to measure changes in brain activity in real time. Now, functional MRI is a powerful tool that allows scientists to track brain function by detecting changes in blood flow. The basic principle behind functional MRI is that when a brain region is more active, it requires more oxygen, and this leads to an increase in blood flow. By tracking these changes, functional MRI gives us a non-invasive, highly detailed look into brain activity during specific tasks. In the case of this study, it allowed the team to observe the neural processes at play while the musicians were improvising, offering a dynamic view of how the brain operates during spontaneous creative thought. Given the traditional metal instruments are not compatible with the strong magnetic fields of an MRI machine, the researchers designed a custom-built, non-metallic MIDI keyboard. This keyboard was made of materials that would not interfere with the MRI's magnetic field, ensuring that it could safely be used inside the scanner. This innovation was crucial because it allowed the musicians to perform as naturally as possible while being inside the MRI, avoiding any technological limitations that could affect the authenticity of their improvisation. Participants were asked to play this keyboard while lying in the scanner, which allowed the researchers to capture both their brain activity and musical performance simultaneously. In order to study improvisation in a controlled and systematic way, the researchers set up two performance conditions: the control condition and the experimental condition. In the control condition, participants played a well-practiced, memorized piece. On the other hand, the experimental condition involved improvisation. In this case, participants were asked to freely improvise over a chord structure, just as they would in a typical jazz jam session. The improvisation was not scripted, and there was no predetermined melody or harmony. The musicians were free to express themselves musically in real time. This allowed the researchers to examine how the brain engages in creative behavior under more natural, unstructured conditions. Now, the study involved 6 professional male jazz pianists, all of whom were right-handed. These musicians were carefully selected because of their extensive improvisational experience. And as we already mentioned, to gather this data, each participant performed 2 types of tasks inside the MRI scanner. During the improvisation condition, the chord progressions were played to the participants through headphones, allowing them to create melodies and harmonies on the spot. To ensure the accuracy of the data, both MIDI and audio recordings were captured throughout the performance. The MIDI data tracked the precise notes, rhythms, and timing of the musicians playing, while the audio recordings provided a direct representation of the sound produced. These 2 data types helped the researchers analyze not just what was played, but also how the musicians' performances evolved over time, offering insights into the cognitive and emotional processes underlying improvisation. Now, let's talk about the brain activity in improvisation and the results of this experiment. Let's take a look at what the MRI scans actually showed. This is where the study really gets fascinating because we can literally see how the brain behaves differently when a musician is improvising versus when they're playing something memorized. The key finding was this. During improvisation, there was significant deactivation in the dorsolateral prefrontal cortex. This part of the brain is usually responsible for self-monitoring, inhibition, and executive control. Essentially, the part that checks your work as you go. So when that activity decreases, it suggests the brain is suspending its inner critic and allowing for more unfiltered expression. At the same time, the medial prefrontal cortex lit up with increased activity. This region is tied to internally motivated behavior, emotional expression, and autobiographical narrative, all of which are central to artistic creativity. This supports the idea that when we improvise, we're tapping into something deeply personal. Beyond that, sensory motor and auditory regions were also active, which is expected since participants were playing and listening in real time. But what's really interesting is that areas linked to language processing and emotion also showed increased connectivity, suggesting that improvisation might draw on similar brain networks as storytelling or expressive speech. So, in essence, the scans show a shift in control away from top-down, self-regulating processes and toward more intuitive, expressive, and emotional ones. So, what does all this tell us about creativity and the brain? The study reveals that improvisation relies on a unique brain state, one where the usual filters are dialed down and expressive emotional networks take the lead. That's a powerful insight because it suggests that being creative isn't just about having ideas, it's about letting go of control and trusting internal flow. It's a bit like turning off the editor in your head and letting the artist speak freely. When we think about creativity in music, language, or problem solving, we often imagine it as a kind of spark. But neurologically, it may actually involve a release of control, allowing more spontaneous processes to guide action. And that's exactly what the study points to. A reduction in prefrontal inhibition paired with a boost in self-expressive networks. As someone with a background in jazz piano and vocals, where improvisation is a central element of my musical expression, this research resonated deeply with me. I've always sensed that something shifts when I let myself play or sing freely, and now I know there is a neurological basis for that experience. This study doesn't just explain what's happening. It also validates the creative process as a genuine, brain-supported phenomenon. So, while this study provides some fascinating insights, it's important to acknowledge its limitations. For starters, the sample size was quite small. Just 6 professional male jazz pianists. This raises a key question about generalizability. We don't yet know if the same brain activity would be observed in musicians of different genders, cultural backgrounds, or even different levels of expertise. As a vocalist who frequently improvises, I find this particularly interesting. The brain processes involved in vocal improvisation might quite differ from those in instrumental improvisation, or at least be influenced by the unique elements of voice production. For example, when I improvise vocally, my voice is directly tied to emotion and breath control in a way that might differ from the physicality of piano playing. Does the brain respond differently when we improvise using the voice versus the piano? That's a big question I'd love to see explored in future studies. Now, jazz improvisation, with its highly structured yet free-form nature, may engage different brain systems than, say, improvisation in classical music, electronic music, or even folk music. The ways musicians interact with their instruments, whether it's the piano, guitar, drums, or voice, could be influencing the brain's activation in different ways, and this needs to be explored further. The study, as it stands, focused primarily on piano improvisation, but what happens when the same experiment is conducted with different instruments, or even across various musical genres? How does the brain react to the fluidity of jazz compared to the more rigid structures in classical music? Another exciting direction for future studies would be examining average versus expert improvisers. Do experts experience these neural shifts more intensely, or are they better able to let go of conscious self-monitoring? How do these findings change with experience? This could inform how we approach musical training, helping us understand how to foster creativity at various stages of development. Finally, brain training and neuroplasticity in musicians could be explored. Can regular improvisation actually enhance cognitive flexibility? Does improvising in the context of music therapy or educational settings have long-term effect on the brain's creative processing? This is something I find particularly intriguing, as music therapy is something I'm passionate about. And understanding the neurological benefits of improvisation could open up more possibilities for therapeutic applications. In short, while this study lays an important foundation, it also opens up a ton of exciting questions for future exploration. And as a musician, the thought of delving deeper into how improvisation shapes the brain, especially across different instruments, is something I'm very eager to see unfold in the coming years. And that brings us to the end of my presentation. I hope you found this exploration into the neural mechanisms of jazz improvisation as fascinating as I did. Thank you for listening.